Tides also influence surface currents, especially near the shoreline. Tides are caused by the pull of gravity from the moon and the sun, and the moon, of course, is our closest celestial object, and then the sun is just the most massive one, relatively close to us. And so both of these exert a force that pulls the water on Earth, and of course land masses can't move easily, but water does move and deform based on forces. And so this gravitational pull creates tides on Earth and causes the water to move around slightly. And this is not just caused by the moon. So often we hear in popular culture that it's based on moon phases, and it is, but it's not just the moon that's pulling that water, it's also the sun. So the moon is closer, and that helps in terms of the amount of force that it exerts, but the sun is more massive. And so if you look at that oppositional force difference, we see that the moon exerts more force, but the sun exerts about 46% of the tide generating force of the moon. So both of them are important when you're looking at tides and what's causing the tides. So for our first check-in question, it asks, which celestial object has the strongest gravitational pull on Earth and water? Is it the sun, moon, Mars, or clouds? Okay, so hopefully you've answered this in your head, and it should be B, moon. So we just discussed the fact that the sun and the moon are both exerting force on Earth and the water on Earth, which causes these ocean tides. And so because of that, it's the combined locations of the moon and the sun that are really important in terms of the tides and whether tides coming in or out. So the good thing about this is if we look at the moon phase, so if you look up in the sky and you see the moon and it has different shapes, the phase of the moon or the shape of the moon that you observe tells you the relative locations of the moon and the sun. So when you have a full moon, as we see on the very left hand, so this image is showing the sun and the rays of the sun going to Earth, which is in the middle, and then the moon is lit up, always the side that's facing the sun, that's the side of the moon that's lit up. So that's shown in white, and then the dark side of the moon is the side that's not lit up by the sun, and that's shown in black. And that moon is constantly going around the Earth. So when the moon is on the far side of Earth from the sun, we can see the entire lit up face of the moon, and that's a full moon. So as long as there's not an eclipse going on, the full moon is what we see when the moon is behind Earth, away from the sun. When the moon is on the side of Earth, between Earth and the sun, that's the new moon. So the lit up face of the Earth is facing away from Earth, and so we don't see, we just see like a very dim disk in the sky or nothing, and that's because the dark side of the moon is facing us during the new moon, when the sun is lighting up the side that's facing away from Earth. And then we have the two quarter moon phases, which is when we can see half of the lit up side of the moon. And that's when the moon is kind of above or below Earth relative to the sun. Knowing that the moon phase and the locations of the moon, sun, and Earth have this very regular pattern, then we can talk about how this impacts currents and the strength of different tidal currents. So there are very strong tidal currents, what we call a spring current. These occur when the moon and the sun are in a direct line with Earth. So when you have a new moon and the sun and moon are directly in line with Earth and the moon is between the sun and the Earth, that creates a very high tide and so that's a spring current. Similarly, when the moon is on the opposite side of the earth and you have a full moon from the sun, then you also have a very high tide. So when the moon is at a full phase or a new phase, that's when you have these strong tidal currents, which are called spring currents. Conversely, you have neap currents, which are very weak tidal currents, and these occur when the moon is in its first and third quarter phases. So that's when the moon is kind of above or below. It's not really above or below, relative to the sun, above or below Earth, and compared to where the sun is. So that means you have two oppositional forces going on. The moon is pulling the tide one direction, and then the sun is pulling the tide in the other direction. And the moon does win out, so you do get a high tide where the moon is, but it's battling that gravitational pull of the sun. So the current just isn't as strong as it usually would be during the other phases of the moon. And again, that's called a neap current. For our next check-in question, we ask, strong spring tides occur when the moon is in which phases? So we said there were two phases in which you get these really strong tidal currents called spring tides. Okay, so hopefully you paused and looked back if you didn't remember, or you just knew the answer should be C. The full and the new moon phases, those are the ones in which you have the strongest tidal currents, which are called spring tides. So when the tide comes in, when you have the tide coming in, that's called a tidal flood. And the floods occur when water moves towards the land from the sea. So that means the moon is over that part of the Earth's surface. And then a tidal ebb is what happens when the water is moving away from land out to sea. So that means the moon has moved away from that part of Earth's surface. And these are called rectilinear or reversing currents. So they go in and out vertically from the land surface to sea and back and forth. When this happens, so when the water moves in vertically, you have this tidal flood coming in, that causes the water that's along the coastline to move horizontally along that coastline, and that creates these other currents that you like if you're at the beach, these can be problematic because they can cause a current that moves along the coastline and pulls people along. So in coastal rivers and estuaries, there's a period that's called slack water, and that's the period between the ebb and the flood tide when there's no movement. So that's a relatively calm period that occurs, that slack water. So make sure you know which current is coming into shore and which current is moving away from shore. Remember that the ebb current is moving away from the shoreline and the flood current is coming into the shoreline. There's a little animation of this at this link if you'd like to check out the animation. It's pretty simple, but it might help you just keep those in check. Your next check-in question asks, ebb currents are moving blank. So fill in that blank. Are they moving perpendicular or along the shoreline? Are they moving from sea to land or from land to sea, which is option C? Okay, so ebb currents, the answer should be C. That's when the tides are moving out from the land to the sea, and along the shoreline then the tide will be going down, so there will be more shoreline exposed. The opposite would be true for flood currents. That's when the current is moving from the sea to the land, and the water line will move up the shoreline, and so there's less shoreline exposed. And And of course, tides for some reason are very discussed in the literature, and there, if you live along the coastline, you kind of live by the tides. When is the tide coming in? When is the tide going out? When are you going to have dangerous cross currents? And when can you go have a picnic on the beach because the tide will be out far enough? So because of that, there's just a lot of funny quotes about tides that I've put on here, this slide.